A test rocket. A test rocket starting from rest at point A is launched by accelerating it along a 200-meter incline at 1.9 meters per second square. The incline rises at 35 degrees above the horizontal, and at the instant the rocket leaves it, the engines turn off and the rocket is subject to gravity only. Ignore the air resistance. Okay. Find the maximum height above the ground that the rocket reaches and the rocket's greatest horizontal range beyond point A. So the rocket will be launched from rest at point A, go through this incline, and then it will have this projectile motion. Okay, so first of all we start from rest, so V0 is equal to 0 meters per second. The velocity as a function of time is at when it's accelerating along the incline, so it's going to be 1.90 t, and the distance we travel, delta r, will be integral from 0 to t v of t dt, which is 1/2 at square. So this will be 1/2 times 1.90 t square, which is 0.95 t square. Okay, now when delta r is equal to 200 meters, the rocket will leave the surface. So when delta r is 200.0 meters, the rocket leaves the surface. So we set delta r is equal to 200, which is 0.95 t square. So we find that t is equal to square root 2 delta r over a, which gives us for t square root 200 over 0.95, and it leaves with a speed v prime, which is at time t, at, that's going to be equal to 1.90 square root 200 divided by 0.95. Okay, so it's going to have an x component of the velocity vx prime, which is v prime cosine 35. So this will be equal to a square root 2 delta r over a cosine 35, which is square root 2 delta r a, because it's a square in the square root. It's going to be square root 2 delta r a cosine 35. And its y component, vy prime, will be v prime sine 35. And that will be square root 2 delta r a sine 35. Okay, so at this point, the rocket is basically here. It's leaving the inclined surface to basically fall. So it started from rest, launched by accelerating it along an incline, and at the instant the rocket leaves the incline, the engines turn off, so this acceleration is no longer there. We're under the influence of gravitational acceleration, and it will be falling under gravity. Okay, so part A asks me the maximum height above the ground the rocket reaches. So the maximum height is going to be reached when it's y component of its velocity when Vy is equal to 0 meters per second. Okay, so we need to know how Vy changes with time. So Vy as a function of t, it is the initial velocity Vy prime minus gt, because now we're under the influence of gravity only. The maximum height reached, delta y max, will be equal to the time from 0 to time t, Vy prime minus gt dt. Now time 0 is now when I'm at the top of the incline. So this is basically t equals 0 for the rest of the problem. So this is going to be evaluated at t is equal to t max. So this will be equal to Vy prime t minus 1 over 2 gt square evaluated at t max. Okay, so when is the y component of velocity 0? So when I have Vy prime minus gt max is equal to 0, so I find that the maximum height is reached when the time is Vy prime divided by g. Okay, so the maximum height is reached when the time time is equal to t max, which is Vy prime over g. Of course, I have reset the timer from t equals 0 to be the time when it leaves this incline. So this is t equals 0, and then at t max it reaches maximum and it's going to fall down. Okay, so delta y max will be Vy prime t minus 1/2 gt squared evaluated at t max, which is Vy prime times Vy prime over g, substituting for t max, minus 1 over 2 g Vy prime square over g square. So as you can see, one of the g's will cancel here, and this is going to give me a Vy prime square over g minus Vy prime square over 2g. So this will be equal to Vy prime square divided by 2g. And for Vy prime, I substitute square root 2 delta Ra sine 35. So it is 2 delta Ra sine 35 squared divided by 2g. 2's will cancel, and I will be left with a delta y max, which is equal to a over g delta r sine square 35. So this is 1.9 divided by 9.8 times 200 times sine square 35, which is 12.8 meters. Okay, so now I have to be careful, because here it's asking me the maximum height above the ground. So this is the maximum height I reached above this level, and then there will be a maximum height above the ground. So there is this height, and then the height I travel above the level, the surface of the incline here, and this is going to be my maximum height above the ground. So I calculate H maximum by considering the triangle. 200 sine 35 will be basically this height, 200 cosine 35 is this range, so it is 200 sine 35 plus delta y max, which is 200 sine 35 1 plus 1.9 over 9.8 sine 35. If I take this into 200 sine 35 parentheses, and the answer is 127 meters. By keeping the smallest number of significant figures here, the smallest number of significant figures was 3, so I keep 3 significant figures, 127 meters. And for part B, I want to know the rocket's greatest horizontal range beyond point A, so the distance traveled beyond point A. Once again, I will do a calculation starting from here and then also consider this part, the initial part of the travel. So Vx, the x component of the velocity as a function of time, is equal to its initial velocity Vx prime, which was square root 2 delta Ra cosine 35. Okay, and delta x, the distance we travel on the x-axis from time t equals 0 to t, Vx of t dt, which is square root 2 delta Ra t cosine 35, and the maximum displacement delta x max will be at final time, the fall time tf, square root 2 delta Ra cosine 35. Now, what is the fall time? The fall time is the maximum time, the time required to reach the maximum height, plus the rest of the time, t double prime, where I'm going to have, since I have reached at t max this maximum height here, I will be falling h max to reach the ground. So it's going to be the time it takes to fall h max, 1/2 under the influence of gravitational acceleration, 1/2 g t prime square will be equal to h max. So t prime, t double prime will be equal to square root 2h max over g. And I also have t max is equal to vy prime over g. So the fall time tf will be equal to vy prime over g plus square root 2h max over g, which is square root 2 delta Ra sine 35 over g plus square root 200 sine 35 parentheses 1 plus 1.9 over 9.8 sine 35 and this will be divided by g, 9.8, square root 2h max over g. Okay, and this is going to become square root 400 times 1.9 times sine 35 over 9.8 plus this quantity. If you evaluate this, you will obtain 6.71 seconds. So this is going to give me for the fall time equals 6.71 seconds. Delta x max will be equal to 6.71 square root 2 times 200 times 1.9 cosine 35, which is 151.6 meters. And finally, after calculating this delta x max beyond the point where the engines shut off, I have to consider the contribution from this part. So that's 200 cosine 35. So I will find that as the final answer, the range beyond point A will be 151.6 meters plus 200 cosine 35, and the answer will be down to three significant figures, 315 meters. Okay, so to summarize, we have a test rocket. The rocket accelerates with acceleration 1.9 meters per second square up this incline, travels a distance 200 meters. When it reaches the top, the engines shut off and it basically has an initial velocity now. With that initial velocity, it's going to fall down. So we want to know the maximum height above the ground and the maximum distance we travel beyond point A. So for this, first we considered the time in the time it takes to reach the top of this incline. So at this in this interval between 0 and time t, when I'm traveling here, the velocity is at, the delta r is 0.95 t square, 1/2 at square, and the delta r is 200 meters, so the rocket leaves the surface at this point. What is this point? When time is equal to square root 2 delta r over a, or 200 is equal to 0.95 t square. So at this point it leaves with a speed at, which is 1.9 square root 200 over 0.95. It will have, when we are leaving with a velocity here, it will have an x component and y component. So x component is v prime cosine 35, y component is v prime sine 35. So with v prime equals to square root 2 delta ra, it is a times square root 2 delta r over a. Cosine gives us the x component, sine gives us the y component. For the maximum height reached, I have reset my timer. Now I'm counting from t equals 0 to t max. When I reach the maximum height, it will have a y component of velocity equals 0. dy dt will be equal to 0. That's the extremum point. And vy as a function of t is its initial velocity y component, vy prime minus gt, because we only have gravitational acceleration at this point. So we travel with a distance delta y, vy prime t minus 1/2 gt square, evaluated at t max, where t max is found by setting the instantaneous velocity to 0 at that point in time. T max is vy prime over g, so we substitute this here and we obtain 12.8 meters. Now we have the additional distance traveled when we were traveling on this incline. That's this height here, that's 200 sine 35. So it is 200 sine 35 plus delta y max beyond that point. So we obtain 127 meters. And for the x component, we have a constant velocity motion. Square root 2 delta ra cosine 35 is our constant velocity on the x-axis, and x component, and the distance we travel is integral 0 to tv of t dt. So where this time the total is going to be the fall time. So what is the fall time? Fall time is starting our timer at this point, at the top of the incline. How long does it take to finish the projectile? So we start with this initial velocity and we reach the ground. How long does it take? So that is Vy prime over g, the time to reach the maximum height, plus time to fall from the maximum height to the ground. And that will be 1/2 gt squared, gt double prime square is equal to h max, so square root 2 h max over g. And we already know what h max is, it's here. We basically also know what T max is, Vy prime over G. We substitute the numbers and we obtain the fall time to be 6.71 seconds. That is beyond the top of the incline, and the distance we travel is 151.6 meters after that point on the x-axis, since we already have 200 cosine 35 that we traveled initially when the engines were on. The total distance traveled turns out to be 315 meters. That is greatest horizontal range beyond point A. So this is the total distance we traveled. This is delta x max here, and then we have the distance traveled initially. So we add them up to obtain our final answer.